Okay guys, welcome to this video. In this video we are going to talk about service level agreement, the metrics or the most important metric for any service level agreement. We're going to talk also about availability. I have a couple of blogs here to read about. I spent some time this morning just reading through all of this research, and I want to drive you to what I think is the best ideas you can get from this video about several levels agreement, the metrics, availability issues, and we're going to discuss an interesting case, use case study with Stripe, how Stripe was able to maintain 6.9% availability. If 6.9 is 99.9999% availability during high traffic periods with Black Fridays and Cyber Monday. And I think this is very interesting for us to understand how big companies achieve this type of things and how they really use the several level agreement metrics to understand and how the business it will get impacted. So let's start with this blog post that I have here on my screen. So let's start reading about this because it's not big. And after that, we're going to jump to the other availability of time blog post that I have here, and we're going to deeper in later on the case study, try to understand how Stripes was able to reach this very good uh, very good SLA. Okay, so let's start from the beginning. Measuring the performance of a service level agreement is crucial to assess the effectiveness of a custom service provider partnership. A well-established SLA, service level agreement, provides the basis for this assessment, but it's important to have a method for evaluating this performance. Okay, so we are going to talk. So if you're using Azure or AWS or GCP, any cloud provider, you will see that every services that you will use, you need to understand what is the service level agreement. And this is a common mistake that I see in most companies. There's a lot of companies that uses the services in their architecture, but they don't know the service level agreement, the SLAs that these services contains. They don't even know if these services are used sequentially or a parallel, which it will affect the availability, uptime, or your general design, right? We're going to discuss more about this later. As technology becomes more advanced and more important to day-to-day business operations, ensuring a high level of customer service and customer satisfaction can become a challenge. You need to understand this. I think this is highlighted in one of the lines above, but I want to highlight it really quick for you right now. 1 second or maybe 5 seconds, 1 minute for some business, 1 minute down for some businesses, it will impact considerably in a lot of money. Okay, so and I think this is one of the reasons every one of us software engineers should research this to understand how these specific downtime or uptimes metrics can impact your business. Okay, to address these, companies must include several level agreement in their contract to clearly define expectations and responsibilities and coordinate all parties in the effort to provide satisfaction service. In this article, we explain the importance of service level agreement and the benefit for service providers and customers alike. We also discuss the importance of regular evaluating service level agreement and share some of the best SLA metrics. And I believe that what the reason he specified, or she, the one that wrote this blog, specify regularly evaluating the service level agreements is not because you were able to reach in the past year a 99.9% of uptime. You will be able to achieve it in next year, because in software engineering nothing gets for granted. So it's very important for all companies to regularly evaluate your services and see if your service level agreement that you already have in plan coincide with the one you are researching, with the one you are just getting again. A service level agreement is a contract between a service provider and a customer that specifies the service or level of services that the service provider undertaken to provide to the customer. The SLA is an important part of any service-based relationship, and it sets clear expectations for both parties and provide a framework for maintaining the relationship. So several levels agreement is a group of things, okay, and availability is one of them. Okay, I want to make that clear because I think I didn't. SLA typically includes details such as the scope of the service, which is precise description of the service to be provided, system availability, response time, and troubleshooting times, service level target, specific metrics, and target value for performance. 99.9 availability, maximum response time of 1 hour, for example. Responsibilities, definition of the tasks and duty the service provides to the customer. Communication processes, definition of the communication channel, frequency, and content of status report in case of any problem. Problem management, definition of the procedures for reporting, prioritizing, and resolving problems. Contract terms and termination conditions, and credit and penalties. SLAs can also include details such as how service requests are handled, how issues are tracked and resolved, and how the relationship is reviewed and updated over time. As you can see, server level agreement is just a group of specific tasks that any service provider must give, or any specific company that has some specific services on the internet. Okay, SLAs are used across all industries, for example, information technology, telecommunication, web hosting, and numerous other service-based sectors such as healthcare, transportation, and public administration and authorities. Okay, why is important to evaluate service level agreement? Service level agreement are important part of any service-based relationship as they set clear expectations for both parties and provide a framework for managing the relation between customer and client, right? Um, Between the company and the customer or clients. However, the SLA to be effective, it's important to regularly evaluate them to ensure that they still meet the needs of both parties. We already talked about this. Okay, the following are the few reasons why it's important to evaluate SLAs and what benefit can result from this. Ensuring service quality. Okay, this is clear. Identify and fix gaps. Cost saving, compliance and regulation, and maintaining business continuity. I said these 5 items I think they are very important, and for my experience, it's very hard to understand them on the beginning you are designing your system. Okay, so that's why you keep evaluating all the impact from these 5 lenses and maybe more. You can I think we can put more ideas here to that can be impacted by the specific system you are designing, right? But let's talk about the most important metrics that any server level agreement should consider. Server level agreement metrics are used to measure a service provider performance against agreed service level goals. These metrics are an essential part of SLAs. They offer both parties a way to objectively measure the quality of the service and identify areas for improvement. The actual number of SLA metrics you want to track depend on the service provider and your organization's specific needs. This makes a lot of sense. Operating this time. Uptime is a measure. I think to be honest with you, I believe that these 8 metrics should be really considered and measured by any company. And I believe that's why they put these 8. Okay, you maybe some emphasis, maybe some companies make some emphasis on availability, or maybe on throughput, or maybe on latency issues, depend of the actual service you are giving to the public or to the customer, to the clients. But I believe these are very important without excluding any of them. So let's go read about them a little bit. Operating time. Uptime is a measure of the percentage of time services available and functioning correctly. Let me repeat this. Uptime is a measure of the percentage of time a service is available and functioning correctly. So this is the operating time, uptime. It is one of the most important SLA indicators, and it has a direct impact on the availability of the service for the customer. The goal of high uptime is the reliability of the service for the customer. Uptime is usually calculated based on the total numbers of hours in a given period minus the time the service was unavailable. Okay? Yeah, operating time is just uptime minus downtime. Response time. Response time measures exactly what the name suggests, the time it takes a service provider to respond to a customer request or a problem. It is an important metric to ensure that problems are resolved quickly and efficiently, and therefore has a major impact on the user experience. In general, a slow response time can result in lost productivity and revenue can damage a company reputation. This is true. Monitoring response time allows service provider and customer to identify and fix performance issues before they become a major issue. It also helps ensure that the service meets the agreed level of performance and that the customer receive the expected level of performance. Availability is another important measure that service level agreement has, and is a measure of functionality and reliability of the system of the service. I like the availability concept that I have here highlighted for us, which I believe is more it's simple. It's simple to understand this way. Let's see if I can find it here. Availability. Availability. Every request receives a response without a guarantee that it contains the most recent version of the information. Okay? It's one of the key indicators that companies use to assess the level of performance and availability promised by the service provider. To accurately calculate availability, factors such as plant maintenance time, hardware failures, software failures, network failures, human error, natural disasters, and other unforeseen circumstances um, may affect accessibility must be considered. By carefully tracking these events over time within specific parameters agreed in SLAs, company can hold their services provider accountable for meeting defined goals. A common way for companies to express availability metrics in SLAs is to provide percentages. For example, 99% availability means there can be around 3 days of downtime, 99.9. I'm going to expose you to this table, to this specific availability percent and the acceptable downtimes here, because I think it's better on this explained than just here. But in general, what is important to understand is that 99% availability means only around 3 days, 99.9 around 9 hours, 8 hours and 45 minutes, and five is an exceptional performance, which is very important. Sometimes very hard to reach depending on this of the system you are designing. Okay, you will have only minutes here, but the I want to take a look to this if you wanna see better. Okay, 99.9 availability, 3 nights. Downtime per year is around 8 hours 45 minutes. Downtime per month is 43 minutes 49 seconds. Downtime per week is 10 minutes, and downtime per day is 1 minute. So imagine you have a system that has only 3 nines of the availability, and you can get up to 1 minute 26, 1 minute and a half, around 1 minute and a half seconds, 26 seconds in a day, which in total would be 8 hours 45 minutes in a year. 99.9 availability, 4 nines, is only 8.6 seconds in a day, which makes in a year 52 minutes. So this is very good actually. Okay. Throughput is the measure of the amount of data that can be processed by a service in a specific period of time. I like the definition of throughput that we have here on this specific website. Let's see, which is just, let me just copy and paste it. So throughput is the number of such actions or result per unit time, and latency is the time to perform some action to produce some results. And I think the reason I like this definition more simplified and more generic is because latency is the time to perform some actions or to produce some results. But these results and these actions can be many things. Okay, you can write to a table, you can send a request, you can request a data set, you can do many things in the IT world. Okay, throughput is the number of such actions or result per unit time. So throughput is the measure of the amount of these specific actions. In this case, he's talking about the amount of data that can be processed by a service in a specific period of time. It is important for services that process large amount of data, such as data center or cloud-based services. Throughput can be measured in various units, such as requests per second, transaction per second, or data transfer rates. This metric is particularly important for services that are expected to receive high level of traffic, such as e-commerce websites, social media platforms, and any other web-based services. Error rate. This is another metric. Failure rates indicate the percent of error that occur when using a service. It's important to ensure that the service is reliable and that issues are identified and resolved quickly. And that's where error rates come in. If a service receives 100 requests and 20 of them result in error, the corresponding error rate is 2%. High error rates may indicate that the service had issues such as bugs, capacity bottlenecks, or other type of issues. By monitoring the failure rate, you can identify problems early and take action to fix them before they become crucial. I think, I think if you want to improve your system, one is in place. If you're using, for example, Azure or AWS, you should put a dashboard. And this is one thing that I done in my past. I never go and release a system without putting a monitoring dashboard in front of all the developers. I believe this works. This works very nice because we can all see that those type of metrics, and we have a. I remember in my last company I had a TV, and we put this dashboard in the TV, and we had a lot of developers looking what was happening in real time to the system we already released. And this was very good because we as a team foresee issues that could be happening just thanks to this specific dashboard, where one of the metric we highlighted there was the error rate on the API request we were handling, the issues on the API request we were handling. We were dealing with a lot of data vendors in that specific case, and more than 47 actually. And I remember that four of those vendors, the error rate of the APIs was increasing a lot, and we had a bottlenecks on the SQL side. So we had to change the backend data services in order to improve that. But thanks to that specific dashboard that we built with this error rate metric, we had the opportunity to see what was going to happen upfront, because we didn't have any issue on production because we saw that specific graph going up, and we took really fast actions, and we didn't have any downtime on um, that specific metric. We were using also a queue in the middle, a service bus queue, to be more specific in Azure. So we were able to hold those requests for a while and retry them and make them inserted in the database once we fix that issue, that bottleneck issue. But again, so visualizing these metrics is very important for a team. And this is one of the tactics that I use in my past. And I really believe they work. Latency period. Latency metric measures the time it takes a service to process a request. Latency plays an important role for real-time services such as a streaming service or online games. The aim here is to keep latency at low levels, which is quite difficult to achieve and maintain due to the various factors such as network conditions, server performance, security, protocol, complexity, or requirement that can influence it. Capacity. Capacity is a measure of the resource available to a service, such as storage space or bandwidth. It is important to ensure that the service can handle the load and is not overloaded. So basically, capacity is just more related with the data layer you have. And I think one of the issues that I have seen on my past is that most companies restrict the capacity in order to save cost. Um, But I think if you understand the data you're you're dealing with, the data set you're dealing with, how big the data set is, and how often, and you have these other metrics, the requests, the throughput, you have the throughput, and you have the specific data layer because you already implemented. I think it's very easy for you to scale it automatically and without spending too much unnecessary space, or in this case, without spending too much money in necessary space that is not being used. So you can scale. What I'm trying to say here, what I'm trying to explain here is that you shouldn't, in too many cases, I believe that you shouldn't go specifically restrict the data layers on capacity. I believe that in the best case, you should set a fixed amount of space for your API, for the APIs can work, or in this case, your backend processes, and you need to understand your data sets, so, and the throughput, these two metrics, so you can calculate how much data you can keep for a certain period of time and how much space you will need in the future. So it's very important for you to understand that sometimes saving some money, it can cause some big issues. So, and capacity is one of the most common error that capacity issue is one of the most common error that I see a lot of API fails, backend processes and services. Okay. Safety, although security itself is a rather big issue and is generally not considered in the standard SLA metrics, there may be some relevant factors that need to be monitored, particularly for services that handle sensitive data such as PCI compliance, penetration testing, encryption measures, access control, and vulnerability management. To be honest with you, I think this is a more deep topic. I think this shouldn't be included in SLAs. On my opinion, I think we should have specific metrics for, or we can call it service level security agreement. I think we should have a different section of the security. In my last company, we were focused a lot of on security, and I really believe that this is a complex topic that shouldn't be included here, or maybe it should be included in several level agreement, but it should be handled by a specialist on security, on my opinion. Okay, because there is not a common developer, a common computer scientist that is not specialist in security. If you put all these type of things, or metrics in a dashboard, it would be not able to understand it. So that's what I believe. This should be separate and should be put in different dashboard, and should put, and this dashboard should be handled by the security team or the IT team that handles this specific IT section. Okay, so what I believe this is important when you're using a specific Azure services or AWS services, any cloud provider, you need to understand the SLAs. And most companies don't understand these, or they don't really do the research on how much is the SLA percent. Because if you are planning to give, I don't know, let's put an example, 5 nines uptime, okay, 5 9% uptime. You need to understand what type of services are able to give you these, and also you need to understand how your services handle the type of request. Let's go about this specific idea because I think it's very important. Um, we have a section here, availability patterns, where we talk about the difference. Okay, here we go. So you need to understand that there is different way to calculate availability, okay? And it varies depending of how you use it in parallel or better in sequence. So let's read this little piece here. If a service consists of multiple components prone to failure, the service overall availability depends on whether the components are in sequence or in parallel. So in sequence, if you have, for example, two services, okay, one of them is 9.9, the other is 9.8. You should calculate both by multiplying. So in the end, So let me read this. Overall availability decreases when two components with availability less than 100% are in sequence. Okay, this is the general rule. Okay, availability total is the availability of one service times the availability of another service. If you have many services, you should multiply all the services availability to get the real availability if they're used in sequence. If both of these two services, in this case they use foo and bar, each had 99% availability, the total availability in sequence will be 99.8. That's why they decrease. Okay, but in parallel is increases when two components with availability less than 100% are in parallel. So in this case, if you have service foo and service bar, and each of them has 99.9 availability percent, the total availability in parallel would be 99.9999%. Okay, that's why I think parallelism is very important to understand. Okay, so this is a very important specific idea that I want to share. We don't want to miss this. So now let's jump about this specific blog post. I talked to you about service level agreement, the metrics that are important. Let's recap those metrics. We have uptime, downtime, operating time, response time, availability, throughput, error rate, latency periods, capacity, security things, okay, related with safety. Okay, now let's go about research deeper what availability means. And we're going to use a specific case here with Stripe, as I highlighted in the beginning. Let's see if we can get this right. Unlike physical stores and organizations that operate during set hours, the IT world never sleeps. Many believe that when an investment is made in technology, it should be accessible all the time, which is virtually impossible to guarantee. Since disruptions occur, organizations should evaluate the service need to run operations smoothly. For example, what services are required during an IT service outage to ensure minimal disruption? This type of evaluation requires organizations to look at several metrics, including a system uptime or reliability and availability. Although these two metrics are often used interchangeably, they are different. So reliability is not the same availability, is what he's saying here. These two metrics lead us to the uptime myth. Uptime does not mean availability. Uptime is the percent. I think this article is very important because before reading it, I use these specific words interchangeably without noting that I was not talking about the same thing. Uptime, reliability, and availability are not the same thing, even they are trying to measure the same thing. Okay, let's read this because it's better explained that the way I could. Uptime is the percentage of time a system is up and running. For example, if your app had no downtime in the past month, its uptime is 100%. With a 2-hour outage, uptime drops to about 99.72. Availability includes uptime and maintenance factors, even if your app runs most of the time. Planned maintenance can reduce availability. Understanding what these two metrics means and what they don't can help manage service provider MSP create accurate and transparent agreements. Okay? What is uptime? Uptime refers to the percentage of time a system is ready for operation under normal circumstances. This metric measures system, solution, or infrastructure reliability and commonly refers to a computer. So uptime is how long a machine has been working and available, expressed as a percentage time. However, uptime does not necessarily mean all services and applications are available and ready to use. When looking at service level agreement, guarantee uptime is determined by past performance. However, it does not indicate what will happen in the future. And this is, I think we already highlighted this specific item. Okay. So yes, uptime can be an indicator of availability, but it's by no means a guarantee. The Great Google Outage in 2014 is an excellent example of how 100% uptime is impossible. During this outage, service to Google applications such as Google Plus and Gmail was down for around 55 minutes, affecting approximately 10% of the users. This example show the conflict that exists between IT reality and consumer expectations. In the year to follow, more outage occurred for Google, Facebook, Intel, and Amateur for and more. Regard consumer expectations remain high. IT professionals know that 100% uptime is a myth, which is why technology is so essential when aiming to deliver a level of service availability that ensures positive customer experience. Okay, now what is availability? Availability, in contrast, measures the proportion of time a system is accessible and operational, factoring in both uptime and schedule maintenance. It reflects overall service reliability, accounting for active operation and planned downtime. This metric is critical when a team is working remotely. Okay? When companies when comparing these two metrics, consider the difference between uptime and availability as overall equipment effectiveness. I never hear about this word before. And TEEP, total effective equipment performance. Understanding both of these metrics is important because incorrect assumption can be costly. Viewing this metric incorrectly will often lead to a poor experience. Service provider will meet the threshold in their agreement, but the level of service will be lower than the customer expected. This phenomenon is what is referred to as a watermelon effect. Output can meet the final target, but the outcomes is not achieved, leading to unhappy customer. Diving deeper into the watermelon effect. So in this section, we're going to talk about that specific, what they mean by watermelon effect, which, to be honest with you, was the first time that I heard about this. The watermelon effect is the byproduct of thinking your IT metrics meet all requirements. However, the customer has a poor experience. Metric looks green on the outside, but on the inside they are red. SLAs reports can look good, leaving the MSP happy. In contrast, customers are not satisfied and take their business elsewhere. Customer experience is essential, so MSP should never underestimate the importance of support metrics. The greater the level of transparency around the end user experience, the easiest is for IT team to focus on helping the end user. Okay. Well, I think it is just being mentioned about the same thing. It's very important to understand the metrics that we just talked about. Okay, and don't get for granted that because you are giving a specific or you target in the past specific metrics, you will be able to get in the future. Okay, you need this type of metrics should be consistently monitored. Okay, the key is to identify issues before they become problems. And observability platforms such as Logi Monitor can help achieve this. Of course, this is the SaaS. Okay, the watermelon effect show metrics that looks good on the outside but high internal issues. The concept of finite. I think we already talked about this one. We're going to skip it. More on SLAs and SLOs. I think we're going to talk about SLOs a little bit here. To ensure outstanding customer service, some SP no longer offer guarantees on SLA, but instead set service level objectives. SLOs are internal goals measured by service level indicators, which track performance against objectives like uptime, for example. An SP might aim for 99.96% uptime on hosted servers. This approach helps measure compliance and avoid disputes. Yeah, it's basically create like so you say that your server level agreement is this, but your SLO are these specifically, or they are different. So maybe you have a bandwidth to work with and say, hey, we have this specific, but we also told you that our target is specific, this number, and you have this specific let's say space in between these two target numbers, so you can dispute if with the customers if any of these issue happen. It's also beneficial to create different SLAs for various workloads. High priority services such as cloud infrastructure may require 5 plus 9 for great functionality, while low priority workloads can tolerate lower performance levels. Essentially, SLAs are external commitment, often with penalty for non-compliance, while SLOs are internal targets that help manage services quality effectively. I think we already explained about how uptime metric and availability metric are tracked. I'm sorry. I think this part is important, so let's talk about this. How are uptime metrics and availability metrics tracked? Calculating uptime and availability metrics is possible, but can be challenging to measure accurately. Network uptime, for example, refers to the time a network is up and running. This is tracked and measured by calculating the ratio of uptime to downtime across 365 days, which is then expressed as a percentage. Here's an example of how to calculate network uptimes. You have 24 hours a day times 365 days a year, which is in total 8,760 hours a year. Number of hours your network is up and running per year divided by this amount of hours times 100, it will give you the yearly uptime percentage. So if your network is down for 7 hours during the year, network uptime will be 99.92%, right? This is wrong here. Again, uptime is directly related to the past performance, which is why challenges arise. For example, a cloud solution with a 99.999 SLA commitment may be available. However, vulnerabilities and even cyber attacks can cause outage beyond the vendor's control. If the service is affected for a day, its availability will decrease. When measuring availability, the measurement is driven by time loss. When measuring reliability, uptime, the measure is driven by the frequency and the impact of the failure. This is an important fact actually. When measuring availability, the measurement is driven by time loss. When measuring reliability, uptime, the measurement is driven by frequency and the impact of failure. So in general, availability encompasses both uptime and scheduled maintenance, reflecting the true system reliability. Okay, now let's go to this specific case study. Case study: Stripe reached 99.69 uptime during Black Friday and Cyber Monday weekend. How they did this? Stripe is a leading online payment service provider and achieved an impressive 99. Let me see. Oh, I didn't. Okay, I think we saw here how they reach this. Okay, during the 2022 Black Friday and Cyber Monday weekend. This is only 31.5 seconds of downtime annually, which is insane, demonstrating the exceptional infrastructure and meticulous planning. Okay, let's see what we can learn from this specific use case. Platform uptime maintaining 99.9999% of time during BFCM, handling over 20,000 requests per second and processing more than 3 billion in transactions daily. CTO's insight. David Singleton, the Stripe CTO, noted that even a 5-minute downtime could lead to significant revenue losses in tens of millions. Wow, just 5 minutes can generate more than tens of millions of dollars in losses. This is insane. That's what I believe. This specific understanding this is has some complexity because there are different words that calculate kind of the same thing as I told you, but they don't actually they are related but not the same. Okay, so and if you are working in a big company, for example, and the reason I'm highlighting big companies, maybe you're using whatever company you're using, you would be impacted by any amount of dollars. So you need to be careful on how often your user, your client, or how big your product is, because the bigger your product, the bigger your client base, the higher the cost losses you will have when you have availability, reliability, and uptime issues. A strategy for success: workload and capacity planning. Okay, this is I think these are important. We also talk about this. They simulate a lot and did a lot of testing. They did a lot of simulation and load testing, which means that they simulate the load for the APIs, and Stripe conducted extensive simulation and load testing to prepare for the BFCM traffic. They determined that the necessary infrastructure capacity by ramping up traffic, analyzing system behavior. And that's one of the good things about understanding your throughput, your latency, your capacity, your request per second, because you can calculate in different environments, on different loads, how many resources, how many scalability your resources or your backend services offer, or your system in general need. I'm a backend developer, so for the past 5-10 years I was working on backend, so maybe that's why I have this work on my mind. But in general, means the system behavior in general, right? So peak load handling is very important because you need to understand how your system and infrastructure behaves on peak loads. If you're using Azure AWS, it's easy to manage all these things because you can scale by time, you can scale by load, or you can scale your resources using different metrics. Okay, and this is very easy to do. If you are using on-premise data center, is you need to do this more. It's harder to do this type of testing, and it's harder to scale it automatically. So maybe you need to understand the load very, 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 very good of your system. Okay. Availability and uptime SLAs, ambitious target. While a 4 or 5 night time uptime is common, Stripe exceeded expectation with 6 nights during BFCM, maintaining a 90-day average uptime of 5 nights. Calculation of downtime. Using the power of 10 tricks, Stripe calculated downtime to ensure they meet their availability target. For example, 3 nights availability resulted in approximately 1.44 minutes of daily downtime. Okay, I don't know what is the using the power 10 trick. I have to read about it. Power of 10 trick. Okay, API performance. Payment Intents API achieve a 99.99999 success rate through rigorous stress testing, ensuring high responsiveness and minimal error even under peak traffic conditions. Okay. Lesson learned: workload capacity plan, essential for managing high traffic and ensuring system reliability. This is very important, guys. I believe this is very important. Okay, we did a lot of stress testing, workload testing. We on the APIs we design, and I think this is very important to minimize the error rate of your APIs. Okay, and improve reliability. Stress testing, critical for identify potential issues and ensure the system remains robust under peak loads. Setting ambitious targets, helping in driving the commitment to high availability and reliability. Yeah, I think this is very important, even though it's just the last one. If you had a team, you have an architect, you have an IT team, for example, it's very important for you to highlight as a CTO or as a directive to highlight what you want to achieve, and set your bar higher, because if you don't do that, it's highly possible that you will not overcome the bar you give to the team. So you need to set the bar as high as possible in order to get the system as better as possible. Okay, so I want to give you the end of this video trying to analyze how they prepare this. I found this specific blog post right now, but I have different of them here, that I'm going to highlight here in the research video comments. How they, what is it? So this is a blog post which touch on the main changes they did over the past 10 years of Stripe payment API design. And I'm going to give you, I'm not going to read about this one because this is a long post. But basically, they prepared the API, and it seems they planned the API very, very, very important. This API, so Stripe services is highly and heavily related on the API's payments, okay, process. So the money they get, or the money they can lose, depend on this specific design. So I believe, reading this through, I believe they spent a quite amount of time designing this API, and they put a lot of great engineers in one room, and they did something very curious here. So they closed laptops Paste your question, use colors and shapes, focus on enable real user integration, question every assumption underpinning system APIs, invite domain experts as guests, make decision quickly, know you might change your mind. So they create an environment where they can design these APIs as the highest levels possible. Okay, and they have the people focuses on this specific design, which I believe is great. And they have experts in on the room, and they have a big blackboard, whiteboard, where anyone can give some comments on how they can improve the API. And this was kind of the result of the result of that research, which is very cool. I will put this specific blog post for you can read it. I want to read it, finalize the reading later, but I'm going to include it on this video. Okay, let's see if um, we can read something. Do you know how Stripe achieved 99.9999 uptime during the BFCM weekend? Stripe, a leading provider of online payment services, demonstrated remarkable success during 2022 Black Friday Cyber Monday weekend, reporting out. Yeah, we already talked about this. Introduction: the dynamic fintech industry, where uptime and system reliability are paramount. Stripe achievement during BFCM stand out. This case study delved into the key factors that contribute to Stripe ability to scale for spikes and guarantee uptime during. Yeah, I want to see what they did to get this specific. So let me see. Let me be more clear here. I want to understand this design behind the APIs, the decision they made. We already know they do a lot of load testing, workload testing, stress testing, which help you to determine the capacity of your the capacity that the infrastructure design is able to handle. But what we need to do is, what we need to know is how they did it. What are the key factors or services they use in order to achieve such reliability or SLAs, right? Okay, David Singleton. Black Friday, I think it's the CTO though. Is this the CTO? Yeah, this is the CTO. This is the CTO, David Singleton. Black Friday, Cyber Monday is a big deal for our roster. So it is a big deal for Stripe too. We handle billions of monies in sales each day of BFCM, a 5 minute downtime, 10 of millions in lost revenue for a user. Yeah, Stripe is very used by a lot of other vendors, big vendors. So this is very important for them. Okay. Okay. 20,000 peaks response per second. Okay. Workload and okay. Here's how we have how this was done. Workload and capacity planning. To achieve such remarkable uptime, Stripe invested heavily in workload and capacity planning. They simulate BFCM scenarios by ramping up traffic and conducting through load testing across the entire infrastructure. During BFCM, which is Black Friday and Cyber Monday days, Stripe handled peak loads of over 20,000 requests per second, processing over 3 billion in transactions daily. Okay, this level of demand justified the cost of robust capacity planning. They have a paginator here, Kotlin simulating BFCM load. They have Stripe API, the backend infrastructure, which is not clear for me how they have this design. Availability measure of the percentage of time. We already know this. Why if oh man. I stopped reading because I found this, but it doesn't give me any information on how this was done. He's just explaining availability metrics. That's all. Um, Yeah, this is just the same thing that is highlighted here, uh, which is insane. Basically, we have a summary of what we have here, and it was just highlighted here. But still, I don't know how this was done, and I wasn't able to find. I was trying to see the architecture diagram for Stripe, but I can't see anything that I really can understand what services what they use. Maybe if you find something, can you highlight it here on the video comment? Because I really want to understand what services they use to achieve this. It seems they use CQR pattern, which is good. There's nothing here I can see. Where I can find the API, the Stripe, the Stripe architecture system. Let's see.
Hello everyone, welcome to my YouTube channel. In one of my previous videos, which you can find the link here, I designed Uber. While designing Uber, I also discussed that many using maybe Shopify, and then they integrate with Stripe to charge their customers for the good companies to make on the Stripe registers a master merchant account with Stripe. Stripe that the transaction updates the transaction details in its loop and
This is
also
just explaining, but
should
I
be able
still
to
don't
charge in
see a
their full
general.
gateway service
Do the
touch
Buy Buy
that
Buy
maybe you
Go
can see.
has um, the stripe design? These guys are really good. Let's see. So here I'm just analyzing the. So I think we have something here. Actually, nice. Let's see. Okay. So far we have covered two examples. Now we're going to examine a real life example. The diagram below shows the development of Stripe payment API over the past 10 years. Stage 1, 2011, the Stripe API, or what could be described as 7 lines of code, resolved around the charge concept. At this point, it's exclusively handled card payments. Stage 2, 2011, 2015, the Stripe API introduced the token API. Its goal was to enable its customer to avoid the complex and tedious process of adhering to the PCI compliance requirement. Stage 3, ACH and Bitcoin payments enter the scene because this type of transaction needs some time to finalize. Stripe integrated a feedback loop into the API. The change helped indicate the success of the charge. Stage 4, 2015-2017, this stage saw the addition of even more payment methods, including Alipay, WeChat Pay, and iDeal. As a result, the source API was developed as an abstraction to support this varying payment method. Stage 5, 2017-2018, as the number of supported payment methods grew, the team spent several months drafting the unified payment API with the introduction of payment intents and payment methods. Stage 3, up to 2020, Stripe invested 2 years to migrate their clients to the unified payment API. And what is the unified payment API? So basically an API where you can use any specific method to create a transaction. Okay, you have a client, you have a payment intent server. Yeah, I still don't find what I want. I think I'm gonna stop this video here. But the whole idea here, if you find maybe the architecture design of the backend services of the APIs on Stripe, please post it here so I can read about it. I will spend some more time digging because there is a lot of lot of blog posts that I haven't covered in this video in order to don't make it so big. But the general idea, just to summarize and do a recap, it's very important to understand the SLA of your system. It's very important to understand the difference between uptime, availability, and reliability. It's important for you to understand these metrics and to highlight these metrics in your team. And if you have created dashboards that and put them visually in front of all the developers, use a TV or whatever you want, but you want to have these metrics visible. Okay. The other takeaway we learn about this is that stress testing, load testing, investing in this type of efforts can lead to a higher slates because you can plan better the workload of your infrastructure. You can scale based on specific metrics that you already tested, and you can be more prepared for unexpected behaviors on your system. Okay. Of course, this also has an impact in cost, and you have to work with your team to handle this trade-off. But I think it's very important for you to understand the importance of these metrics because they might impact your business and they might impact in the way that your business can get or can lose a lot of money. See you in the next video. I hope you like it. Put the comments here, please. If you find the Stripe architecture design diagram, please share with me because I want to understand how they did this. Okay, thank you so much. See you in the next video. Bye.